Okay, so we're doing a vertex form of a parabola today, or sort of a quadratic. Okay, let's get into it. So a transform version of a quadratic is called vertex form. So we have done y equals x squared, and we already know kind of what the transformation looks like. The general form that we're going to be working with is y equals a bracket x minus h squared and then plus k. We already know this. The number on the inside should be moving the graph left and right. The number on the end should be moving it up and down. And that number in front, it's not inside with the x, so it's outside, which means it should be doing the vertical stretch or compression. We would more so call this one D and this one C. But for some reason, they don't keep it consistent. They call the left and right H, the up and down K. So we're just going to roll with this. They don't put the K value. I know K is usually the horizontal stretch and compression. They don't put it here in front of the X because we just don't do that. We don't horizontally stretch or compress parabolas. We only vertically do it. There's a good reason, but there's not really a reason for you guys to know it. Parabolas, just so you remember, parabola, this is the base graph of a parabola. And we can move this. So it can be moved left, right, up, down. Okay, there we go. You can move it left, right, up, down. You can flip it. And these numbers will tell you what's happening with that. So HK, that is called the vertex. So that is either the maximum or minimum point. The one that we drew up there is a minimum point. If the graph was instead flipped to go down, then that vertex would become a maximum point. Just remember this, that all of our transformation stuff still applies. So H will always be backwards. If it says plus 5, in here you would write minus 5. Okay. Other than that, just a parabola. We use two different words, quadratic and parabola. Quadratic is the math part up here, the equation. Parabola is the picture. Okay. So we're going to do an example. We're going to determine the vertex and whether it's a maximum or a minimum value. I guess I should have the letter A in there. So if it's a maximum or minimum value. So the first one we're going to do is y equals 3 bracket x minus 4 squared plus 2. And if things are going too fast, just remember, you can pause the video at any time. Just write down what you need to write down. Okay. So there are a bunch of rules that you can follow. You can check a bunch of boxes, and that will tell you exactly what's going on here. The best thing to do is just to graph it. Not even graph it. You should just be sketching it. And you've got to look at 3 things to know how to sketch it. You want to look at your left round upright because that tells you the general location of where you're going to be. So for instance, for this specific parabola, I know right away the vertex is at 4, 2, right? Switching the sign of the 4 because it's inside with the x, and then the 2 on the end. So if I were to draw a parabola really quickly, I know I can go over 4, up 2, and that is where the vertex is. The question is it an upwards parabola or is it a downwards parabola? And that's where the 3 comes in. The 3 is the vertical stretch or compression. But remember, that doesn't matter when you're doing sketches. You can't really tell if something's been stretched or compressed. What matters is that does that flip? Does it reflect the parabola or not? And because it's a positive number, it does not reflect it. So it looks pretty much just like the parent function. There's no reflection. So it's just an upwards parabola like this. Now that you have a quick picture, and you can really do this in 2 seconds, you just go left, right, up, down. Is it up or down? It's an upwards parabola. So right here, this vertex, it's a minimum. It has a minimum value. And the minimum value, when I say value, I'm talking about the y value. right? We're really talking about the value of a function. The x is the number you give it, and you're trying to see what gets spit out. That's the value of a function. So in this case, it has a minimum of 4. Oh, of 2, sorry. 2 is the y value in this case. So a minimum of 2. Okay. Let's do b. Oh, sorry. That's my alarm going off. B. We'll do f at x because f at x is the new y. It doesn't really matter what you're writing. Let's do negative bracket x plus 1 squared, and we'll take off 12. So we know the vertex immediately is negative 1, negative 12. Taking that x value, flipping it, and then just the number on the end. So if I quickly graph this, we are going over to negative 1, negative 12. I guess it's not I say it's not a very accurate representation, but if you just throw the numbers down, I have no choice but to believe you. So we'll call that negative 1, negative 12. If you want to make it more accurate, obviously you can put negative 1 over here, but I just want a little bit of space. And then you look at the beginning, the a value, this is called. And then you ask yourself, is it positive or negative? Because it's negative, it will be going downwards. So you draw a downwards parabola. And then you can say, well, where is that? Is that the top or the bottom of the graph? That is at the top of the graph. So this would be a max value. And what is the lowest it's going for? The lowest it's going, or I guess the highest it's going, because it's the top of the graph. You're going to negative 12. So it is a maximum value of negative 12. Okay. Now, this is a special form. This is a transform version of a parabola or of a quadratic. They're not always given to you like that. So there is the standard form. Standard form of a quadratic. And that would be f at x equals a x squared plus bx plus c. So that is something that you would typically be factoring. You would try and figure out the numbers, right? You would do a times c and do whatever you need to do to factor that into two brackets. That's not what vertex form is, right? Vertex form we just had written down at the start. Vertex form is f at x equals a x minus h squared plus k. This is kind of factored. It's not factored like the two brackets like we would normally have. We have numbers on the end, which we don't typically do. There are some similarities though, which is nice. This a and this a, because they are the same letter, they must be the same. H and K, B, C are all completely different things. There's nothing we can really say about those things yet. Looking at the first one though, there's only there's two things I guess you can tell from it. The A and the C values are important values, but when you're graphing, they don't really tell you enough. You really need vertex form to be able to graph anything. So we are going to go from here to here by doing some special things. One thing I want to say is your textbook calls this completing the square. Completing the square. This is a method for turning standard form into vertex form. We're not going to do completing the square just because it's a lot of remembering and it's not really worth our time. There is a different method that we can do. And most of you might have done this last year. So what we need to do is we need to figure out the h and the k, because the a value is actually already the same as when you start. So let's just look at an example. So this is example 2. The textbook would say complete the square. What we're going to do is we're just going to convert to vertex form. Okay, so for the first one, we're going to convert what? We're going to convert f at x equals 3x squared plus 18x minus 2. So way over to the side here, we're trying to find this. Y equals ax minus h squared plus k. And I already know the a value. This is the a value. So if I'm filling this in over here, I already know it's 3 bracket x something squared. H and the k are kind of the hard parts. So to find the h value, h, there's a little formula for it, and it is negative b over 2a. That's a very important formula to know, and I believe a lot of you did that last year. A and b are based on the standard form, so it goes a is the first number, b is the second number, c is the third number, as long as it goes x squared x and then number on the end. So we're just going to take these values. So your h value is negative of 18 over 2 times 3. So that's negative 18 over 6. H equals negative 3. Okay, that's good information. We want to know h equals negative 3. And what we can do is we can actually now put that into our formula here. But remembering that whenever you put something into a bracket with x, it's always backwards. So if this says negative 3, you're going to come into the brackets and you are going to write plus 3 instead. Okay. Now the thing to remember that this is an x value. The h is with the x, so it must be an x value. To find k is not with x. K is on the outside, so it must be a y value. To find a y value, well, this is the formula to find the y values. Remember that f at x just means y. So if you know what x is, you just plug it in, and then you find y. So for finding k, what you're really just doing is you're doing f at negative 3. Remember, you're taking it out of the equation. You're using the number. You got to flip that number. K is f at negative 3. So we go, okay, 3 times negative 3 squared. Make sure that negative 3 is in brackets, especially if you're squaring it. Plus 18 times negative 3 minus 2. And I believe at the end of the day, I had that somewhere over here. I think it's negative 29. We can do a little check here. This is 9 times 3 is 27 minus something else. I'm just going to punch in a calculator over here because we don't have time for this. 27 minus 18 times negative 3. Minus 2. Apparently it's negative 79. Let me make sure I'm doing this correctly. 18. Sorry, the calculator I'm using is not very good. What is 18 times 3? 18 times 3 is 54. So let's subtract that from 27. Minus 2 is negative 29. Okay. Okay, so then we put minus 29. F at negative 3. So this is k. K is f at negative 3, which is negative 29. And then we have our final number. Our final number is negative 29. So again, just the little formula that we do. A is always A. So the number in front is the number in front. Your special formula here is negative b over 2a. That's the only thing you really need to remember. Once you take those numbers and plug it in, you have your h value. That's one more thing down. To find that k value on the end, you take that h value and you just plug it in for x. Because if you know x, you can find y. And our y came out to be negative 29. Okay. We're going to do one more like that just because the numbers don't always turn out to be super nice. So for part B, we're going to do y equals negative 2x squared plus 5x plus 10. So over here, I know I can write y equals I'm going to have my bracket, my x, my squared, and I know my a value will be my a value. So I know there's going to be a -2 in front. Okay, but now we got to do our h value. So h is -b over 2a. That is -5 all over 2 times -2, because that is our a value, right? It goes a, b, and c. So this one doesn't become so nice. The negative and the negative make a positive. So this is 5 over 4. So I can throw that into the equation over here because it says positive 5 over 4. I'm going to write minus 5 over 4. And now we're going to find the y value. So the y value is based on the x value, which is -2 bracket 5 over 4 squared plus 5 times 5 over 4 plus 10. Now I'm going to make you do all this step by step instead of just punching it all into a calculator. You follow your bed mass, obviously. But one thing I'm just going to remind you is bed mass. You only need to do bed mass if you are given a choice between two options. So the beginning here, you can either multiply the fraction by -2, or you can square it. Those are the two options you have for 5 over 4. Bed mass tells you which ones to do first. So it's telling me if there's an exponent, exponents come first. So I'm going to do -2. And how you square a fraction or how you exponent any fraction is you just do the top, square 5, square 16, or square 4, sorry. 4 to get 16. Okay. That means I'm allowed to do this one at the same time. Because again, the options are either multiply this fraction by 5, or I do 5 over 4 plus 10. And multiplying comes first. So plus, now if you're multiplying fractions, you need fractions. So 5 is not a fraction. Make it a fraction by putting it over 1. And how you multiply fractions, you just do top to top. 25 over 1 times 4 is 4. And the plus 10, we can't do anything with the plus 10 because addition is supposed to be coming last. Now we can multiply the two guys in front, because that's the last little bit of bed mass I really got to follow. So make sure you put it over 1, because -2 is not a regular number. So that's going to give us -50 over 16 plus 25 over 4. And I'm just going to go ahead and, well, no, I'll just write 10 now. We'll do all the changing now. So to add this all together, we need a common denominator. The easiest one would be 16, because 4 goes into 16. So the first fraction can stay the same. Oh, sorry, it's not 150. That is just 50 over 16. And up here, we're going to need to multiply this guy by 4 and this guy by 4 to make the common denominator. So 25 times 4 is 100 over 16. And then plus, we got to multiply this guy by 16 and by 16 times by 16 times by 16. That will be 160 over 16. And if you add all this together, you get 210 over 16. Which simplifies to 105 over 8. So at the end of all of that, this, remember, is your y value, but it's really your k value. Because h and k occur at the same time. That's the x value of the vertex. This is the y value of the vertex. So once you plug in your h or your x, you can find your k. So we have a plus 105 on the end. Okay, so the numbers don't have to be nice. Do not ever change this to a decimal. Because the second you get a gross decimal that repeats forever and you cut it off, all the numbers are technically wrong. So I don't want to see that. I just want to see fractions. Okay, we're going to do one more. We're going to do a little word problem about this. So Natalia is making a rectangular garden with 90 meters of fencing. And I want to know what the max area she can make is. And then what are the dimensions. So first thing, let's just make a little picture about this. Here's a rectangle. 90 meters is all the way around. Okay. Now, I'm not telling you like you could do 1, 1 that takes off 2, and then you're left with 88. So then you go 44 and 44. That's one of the best things, not the best things. That's an option that you can do, but we want to have a maximum area, and this is what you need to be looking for: is these words that say maximum or minimum, because that immediately tells you that you need a vertex, because the vertex will tell you what the biggest or the smallest thing is. So what we're going to do is we're going to say that this is x. There is some sort of width here. Okay. And then if we have 90 meters of fencing, okay, well, first of all, if this is x, this is x. Your total perimeter is 90. So perimeter, well, first of all, perimeter is, it's 2 lengths plus 2 widths. This is me kind of just writing it out, and instead of saying all the things, you don't necessarily need to write this out, but you know that 90 is 2 times the length plus 2 times the width. And we called one of them x. So let's say 90 here. Sorry. 90, the length we didn't label, so 2L plus 2x. So then what I'm going to do is I'm going to figure out what would the length be. So I'm going to try and solve for x here. So, solve for L here, because I'm trying to figure out the length. So I'm going to bring the 2x over, 90 minus 2x, and that will equal 2L's. And I need to divide both sides. Now, a lot of people make this algebra mistake. You're going to divide this side by 2 and this whole side by 2. Everybody gets the 2. So when I divide everybody by 2, and not just the x or not just the number, I get 45 minus x equals L. Okay, so 45 minus x, 45 minus x is the length. And what would happen, so this one also here is 45 minus x, and you can kind of just check. If you add all these sides up, you have x plus minus x, which is 0, plus x minus x, that's another 0. So all the x's are now gone. And then you have 45 plus 45, which is 90. So I just confirmed that those are the correct side lengths. So that's your perimeter. Breaking down your perimeter to figure out what your side lengths are. All right. Now that's using the perimeter. That's just using the beginning. That's how we figure out the appropriate side lengths. You just name one of the lengths x because you don't know what it is, and you got to figure out, well, what's the leftover for the sides. They want to know the maximum area, though. Okay? So what we can do for the maximum area, you have to know the area formula, which is length times width if you're doing a rectangle. And now we know what these two things are. Area equals length, 45 minus x, times the width. Oh, we actually know what the width is. The width is just x. Now, if I want to find a maximum, I need to put it into vertex form. And this is not vertex form. If it was, there would be a square, there would be numbers put everywhere. And the only way that so far we know how to make vertex form is to put it into standard form first and then switch it to vertex form. So that's what we're going to do. We're going to take this x. This is still distributive property, even though the x is on the end. It doesn't matter which side it's on. You can always just multiply that guy in. So now this is 45x minus x squared. Now I'm going to make our life a little bit easier. I'm going to write minus x squared plus 45x. Just because I like this to be in standard form, right? X squared should come first, and then the 45 x should come next, and then the plus number should be on the end. We don't have a plus number, so it's really just plus 0. That doesn't really bother us. So this is the formula. This is kind of the y equals that we are trying to maximize. So now we need to find what vertex form is, okay? And I'm actually going to write that down because it's actually a good thing to have. When you see something that says max, it means find vertex. Okay. So this is your standard form. Let's make it into vertex form. So we need to get our h value, which is negative b over 2a. In this case, it's going to be negative 45 over 2 times negative 1 is your a value, because it's just a negative there. And that is negative 45 over 2. Okay, so then your k value, what we're doing is we're finding the area. So it's an area formula. So a equals negative of negative 45 over 2 squared plus 45 times negative 45 over 2. And no, sorry, I've made a mistake here. The two negatives should cancel each other out. I was just thinking that having a side length of negative 45 over 2 doesn't make sense. Yes, negative on top, negative on bottom should cancel each other out. These should just be positive numbers. My apologies. Okay, and then we have to, again, bedmass this. Square this first. I have no idea what 45 squared is. 45 times 45 is 2025. So this would be negative 2025 plus 2025 over 2. That's me multiplying 45 as a fraction. So 45 times 45. And sorry, I keep forgetting all these things now. So this one over here should be negative 2025 over 4. I forgot the bottom of the fraction. Let me just double check and make sure it's all right now. So we fixed that number. We squared it. 45 times 45 is 2025. Square the 2 to make it 4. 45 times 45 is 2025. And then over 2 because 1 times 2. Okay. Then we common denominator it. So the first one's the same. This one would be 4,050. I am not very confident in my math today. 4,050. That's over 4. So that should give me 2,025 over 4. So this is my k value. It's an a value. It's the area value, because that's what the formula is from, but it's also the k value. Now we don't write y equals. You're supposed to use the letters you've been using. So this is area equals. So remember, we can put the x, we can put the squared. We just got to make sure we put all the correct numbers or letters. So our a value, not the capital A, but the little a, is a negative. So we'll put a negative in front. Our h value was 45. So we're going to flip that to a minus 45 over 2. And then my k value on the end was plus 2,025 over 4. Now, I did just give you the big talk about don't ever change this into a decimal because it's not worth our time. The thing is, when you're doing word problems, yes, fractions all the way until you get to the end, because decimals are the universal way to understand things. Fractions are just a lot more accurate. I first of all know that this is a maximum because this says negative. So if I move my parabola right 45 over 2 and up 2,000 whatever to get up there, it's a negative, so it goes downwards. And that is definitely a maximum point. So the maximum area she can make, remember that was the area number we found. So the max area, therefore max area, is, and this is where you can change this into a decimal. So that's 506.25. And what are we working in? We're working in meters. So meters squared is our maximum area. Now for the dimensions of the garden, what we're really doing is once you find the vertex form, we're just checking, do you know what number means what? So this is a y value on the end. So our y value is your a value, area. That number is your area number. X must be the side length number, right? Because in that beginning diagram, we made the side lengths x. So we know that the width equals 45 over 2. And I'm going to say that for now until I give you the final answer. And the length is 45 minus 45 over 2. That would make the length 50 over 2 minus 45 over 2. Just doing common denominators there. Oh, not 50. The reason I'm not there today is because I'm sick. So you can see that's working well for me. That should be 90 minus 45, which is just 45 over 2 again. So the length and the width are going to be the same for this question. And unless you're doing something weird, which there are weird examples sometimes where you change the side lengths or something like this, a square will always give the maximum area. So if it's ever a rectangle question, your length and width should always come out to be the same. That's just a universal truth that we know. And then we can say, therefore, the dimensions are, now this is where you can switch it. Okay, what's 45 divided by 2? It's 20 and a bit, 22 and a half. 22.5 by 22.5 meters.